Okay, it is that time again. Now, I think for this stream I'll have everything muted, but that probably won't be like a guarantee. Yeah, so give me a second. I'll pull up a document and then we will start. I will start putting stuff on this piece of paper. Once I can find a document. So give me a second or two and we'll be starting. But I kind of want to keep it this way. Okay. So a few exam ideas I want to bring. You guys won't see the problems, obviously, but I will try. I'll write down the problems. Math stream where I do problems on the computer screen so you guys can see them. And I explain my thoughts. This is also going to help me study for a test that I have soon, presuming that the snow that's on the ground, the 2 feet of snow that's on the ground, doesn't stop class on Wednesday. So, trying to get into that. Okay. This is actually a pretty good one to start off with. I think I can start making this one. Although it's going to be hard for me to see. I'm going to do it anyway. Hey, Sayun, welcome to the stream. What's going on? Okay. How big is my brush? I think my brush is too big. I think. That's not the brush. This is the brush, and then this is the size of said brush. I think around 12 is... That might be too big. I'll try to zoom in here a little bit. Alright. Alright, so we're at the top. And I'll lower this down a bit so I can see it. Okay, so the first problem I have is... Okay, my handwriting is not good. I'll actually make this smaller. Like around there. Do keep in mind, because I have to do this on the computer, it's a bit more difficult than by hand, but I'll try and do my best here. And then, okay, know what this is? Plus whatever this function I have here is. Okay. Yeah. So plus, that doesn't look right. I need my parentheses to look more like this, just so I can get all the detail I need in there. But that even looks too large. I can decompose this pretty well. 4y. The y goes here, and this is over dt4. And then this is to the third. And then t plus 1 is equal to this. I feel like it was weird that at one point I vanished completely and immediately started appearing out of nowhere from time to time. I mean, it's not that weird. I mean, people do that from time to time. You're still around, which is what matters. I'll actually make this easier for me to see, because I want to condense how much space I'm working with. Even still, I think I even might need to make this shorter. And I think I have t ft plus 1 is equal to that function. It's going to get confusing kind of quickly. Okay, it's equal to this. Now, identifying it, this is problem 1. This is trying to figure out if it's nonlinear or linear. This term is linear. The y term is my dependent term. So this is raised to an exponent here. So that's a red flag. So I'll box this in. This is a red flag here. The function itself was not multiplied by another y function, so that's fine. And then this does not matter. So this here would be nonlinear. And then if I have to draw the directional field, which scroll down a little bit here, not like that. Draw directional field. Actually, hold on. I need to find the asymptotes for this, where the function just stops working. Actually, no, it's a new function. Actually, never mind. I have to make a new function. I'm dumb. Hey, Key, welcome to stream. What's going on? All right, so that's 1A. It's 1B. It's too large of a 1. Part B. It's a different equation. It's this equation. Still way too big. Okay, y prime is equal to y minus y squared. Yeah, y minus y squared. I could just erase this. It's easier. So y squared. Okay. One thing I can do, I can factor this, so this just becomes y 1 minus y. This makes it pretty easy to tell which is what. So I have lines at equilibrium points at these two numbers here. So scroll down a little bit here. Keeping this in mind, I have a direction field, and then I have another line here where we just get lines across. Same thing here. It's going to be quite difficult to get this, but this is y is equal to 1. This is y is equal to 0. Okay, so looking at this, actually, I can't look at it. I need to start plugging numbers in here. When y is greater than 1, I get a positive number here, here. So I get a positive here. But if anything's greater than 1 here, I get a negative number. So this becomes negative. If y is between 0 and 1, I get positive here, positive here. Yes. So this is equal to a positive. And then if anything is lower, if y is less than 0, in this case, then this front term is negative. Always, and then this is positive. So this is another negative. So for what this would mean is I would have my direction fields coming this way, and it would be getting slower as I get down there. Same thing here. It would be going to negative infinity in this direction. So be looking something like that. Whereas in this tiny gap here, it's moving up from 0 to 1. So this is, actually, I'll highlight that in another color. Okay, this is stable, whereas this is unstable. Excuse my handwriting, guys. This is unstable. Reason being, you have a convergence solution here, but here you have divergence, so you don't really have a point here. This is the boundary, but if you're not on the boundary, you're moving away from it. What else? All right, no one else has said anything so far, so I could keep going. If you guys have questions, do let me know. I could probably explain what I have going on. Okay, that part is done. I have another question I had to get to. Find explicit general solution of the following differential equation. Okay. I should know this one. Okay, so can I move up a little? Yes, I can. So number 2, and this is 2a. No, this is just 2, and then there's another one. So 2 would be I have dy dx. Actually, I can move this back a little bit because I want more space. Dy dx. All right, I'm not muted. There we go. Is equal to, in this case, I have 20 square root xy. Yes, that seems to be the case. I have 20 square root xy. xy. Okay. This one's actually a little bit tough now I'm thinking about it because I need to get. Okay, ideally, what I know I need to do is that I need to get this function. Let me highlight it. I need to get y out from underneath here. I need to get over here. I need to do that in some capacity. But I'm not sure if this is something that you can do. Although to be fair, xy to the 1/2, which this is what it is, divided by what? The same thing. Well, by this directly, rather. So, y to the 1/2. Hypothetically, if I did this, then what I'd get from here would be, I still have this x to the 1/2 here. I still have that, but this y will be gone, and then I can port it over. So I'll actually do that. Now I'm thinking about I can multiply this dx over as well, and multiply that on both sides. So I would get dy, and then put this underneath. Not this, but put this underneath. So y to the 1/2 is equal to 20, and then in this case I still have this square root x dx, and now I'm ready to integrate both of these. So now I would integrate both of these factors. Now, from what I remember, I know what this becomes, but I have to get a 1/2, so I'm actually have to put a 2 up here. From my experience, I have to put a 2 up there. Integrating this directly like this, same thing there. Integrating these directly, y over this 1/2. What will likely happen is I have this is square root here, and then take a derivative of what's inside that square root. That will be 1. This y doesn't matter too much for that purpose, but what else is happening? Because I have this 1/2 here, and this would be up here normally, then if I were to flip it, it'd make more sense because this 1/2 will come here, but I don't see that 1/2 here. There should be a 1/2 here, but there's none, so I would assume, just thinking about it, that this would be that there would be a 2 here. So that's exactly what I'm going to do. So I still have this, but I'm going to bring it up to the numerator, and then there will be a 2 in front of here. Because when you differentiate this 1/2 cancels out the 2, and then this y in the square root comes to the bottom. I'm going to just make sure to put that in parentheses. And this will be equal to the same idea here. This square root x, this is 1/2, but this will go to the 3/2. Power here, so I have 2 over 3 in this case, so times this by 2/3, and I would get 40 over 3. Yes, I would get 40 over 3. And then this wouldn't be square root x anymore. This would be square root x to the 3 halves. That's what it would be. And then I'd add a c here. Okay, so now from what I have so far, I would need to divide the 2 over. Both divide the 2 over and then square both sides. So I'll actually do that now. Divide by 2, and then I can condense this over here. So I have y to the 1/2 is equal to, in this case, this would be 40 over 6, which I believe simplifies to 20 over 3. Yes, that simplifies 20 over 3, and then this would just be c over 2. So 20 over 3, x to the 3/2 plus c over 2. Now, I'm not 100% sure if that is correct. It should be somewhat close to being correct, though. Give me a second. I just need to get my phone so I can check chat easily instead of having to tap OBS and keep checking that way. So I'm going to make an attempt to do this a bit differently. Oh my goodness. I don't know if you guys have said anything or if the chat is just quiet. Caster Labs could also be making a mistake where I just don't see any chat messages too. That could be, that could be another thing entirely, but things happen. One thing I will do is I'll actually promote the stream and I'll share it live and I'll post. And it's a bit different. Okay, so back to this. 20 over 3 x 3/2 plus c over 2. From what I know, just looking at this. Okay, 2x squared would be, if you square the term 2x, you would get 4x squared. Okay, so from here, if I square this, I'd get y, be able to get y, but then I have to square this function, which would get rid of this exponent. So I have x to the 3rd here, and then I have c squared plus 2. Now that will be my general solution. Yes, that would be my general solution. And it wouldn't really matter that I squared this because the constant is still going to be the same. So squaring this, I had 400 over 9. So I get y, in this case, is equal, and just bringing this entire function down here. I would get 400 over 9 over 9 x. I'll actually put the x up top, x third, and then this c over 2 here would be c over 4. Not c squared over 4. The constant would change, yes, but we'll just keep it as a constant. So this would be generally what the general solution should be. So I'll make sure to highlight that. And then I'll check that at a later time. I'll make sure just to highlight all my answers while I have time. These pretty easy to tell. I did not want to do that. This is pretty easy to tell here. So I'll highlight this. I got my numbers, and then this is non-linear, so I don't need to mark that. Okay. Speaking of which, other things. What else? We have solved the following initial value problems. Okay, now this can get quite complicated. There are a lot of different problems available here, but I can try my best. Number 4, I definitely have not seen, but I'll have to build a function for that and to just see what I can do. Okay, so number 3, I have to find the equation first. Oh, there's 2 different equations. Never mind. So I know what I'm doing. Solve the initial value problem. Looking at these, at least from my perspective, it seems like I have in both cases, I have a GT scenario. But I'm also kind of thinking that this also might be one of those C1 problems. Yeah, I'm thinking it might be one of those C1 problems here. So I'll write it down just so I can remember and not have to go back. I think this one is definitely integration factor, whereas this next one is not an integration factor. It's much more similar to the coefficient ones. So let me get this down. Okay. Ty1, y prime. There we go. And then there's minus y is equal to that function. Which that function for you guys, in this case, is t squared e to the 2t. Okay. Integrating this is going to be, I would say, pretty problematic once we have to do that. But overall, I wouldn't say it's the worst thing. Ty1 minus y, t squared e2t. Thinking about this, at least thinking about the problem generally, I'm thinking that I need to remove a t here. So let me get rid of this t and get rid of a t from this one and begin working. So y, boom, minus y over t is equal to t e to t. Now, in this case, because it's not a t squared, this is still integration by parts that I would have to do in this case, but that's not really a problem. Okay, so now I have this new function. I know this is my p of t here, so my p of t in this case is equal to -1 over t, and I know to find my u function, it is e to the integration of pt, which in my case is this function here. And I know this is negative ln t, and this would be e. But from the way this works, this would come inside, so it would be ln t -1, and this would be e. So then this would simplify into t -1 or 1 over t. Now, bringing these together, y would be equal to, in my case, I have, actually, there's a lot of things here, but I have 1 over 1 over t, which this logically simplifies, and I get t. So this would be t, and then it would be times, in my case, 1 over t times t e to t. So then in this case, because I have 1 over t and I have times t, what this turns out to become is I just have e to the 2t. And I integrate this function directly. And what I get is, from here, normally if you differentiate, you get a 2 here, because I'm integrating, it's the opposite. So I get e to t over 2 plus c, c being my constant. And now I just times that by t. And this is equal to my y function. Something to note though, I did not actually put my initial value status up here. I did not do that, so I have to do that now. Initial value. So y of 1 is equal to 2. And that's an initial condition. So now that I have this feature here, I'm going to use this rule. And I'm going to say, I'm going to put 2 here. Is that actually what it is? No, I think I messed that up. This is incorrect. This is E2. So I have E to the 2. So that's incorrect. And then this is equal to. In this case, this is 1. This is 1, this is 1. So I get 1 times this. So I just get E2 over 2 plus C. And I need to get here. Now, the real question is, because it's E over T, E2 over this. Technically, adding another one of these E2 over 2 will work. So I'm going to subtract them. And you're going to see why. Because if I times this by 2, then I can subtract this easily. And it will be very easy to see what this actually becomes. Minus this function here. It's probably a little bit too big. E2 and then 2. And then from this feature, this should just be equal to C. C, which is equal to E2 over 2. So that will be the normal function. And now the actual y, bringing this down, is equal to T times. T in that case was 1, but for all solutions, it would be E2T over 2 plus E2. E2 over 2. So in this case, this is the direct function. And this is what it would be here. So that solves my initial value problem. And this was for part A. So I'll make sure to clear label that. So this is 3A. And then part B down here, which I'll outline with a green marker here. So it's easy to delineate what's what. Now I have a different equation, and this is for part B. Gotta see. Really have to see what's going on here. I will admit, it is quite interesting trying to do math, but if no one's here, it's okay. Oh my goodness. Actually, I could promote this in a server that a lot of people would like. So I'll actually do that now while I get the chance before I start the next problem. So I'll post this as a promotion channel, and we continue. Okay, so the question that I was about to do, from what I remember, was, I just skipped over it. It was y double prime plus 9y is equal to 0. Y double prime plus 9 is equal to 0. Now, from this point of view, there may seem like there's not much of, a real path forward here, but there is, because you can convert this. Oh, I forgot this y here. Let me erase some of these. factors. There's a y there. So this is 0. You can convert this into this, because this is what it turns into, right? And now for this case, this is not really a factorable form. So what I can do is subtract this over. R squared is equal to -9. And in this case, this would become R is equal to plus minus 3i. And 3 and I is equal to square root of -1. Now, this is the complex root notation. So this is the complex root notation. And then it's going on from here. What I would do from this point forward would be, okay, you move this up, and is in the general pattern of cosine plus not cosine. I think I forgot to add a constant. Not here. I didn't forget to add a constant here, but for here I have to add them. So I would get from this, I would get C1. And then this would be cosine 3t plus, plus, a bit smaller than that when possible, plus C2 sine 3t. And that will be the second function. Now, the goal here is to figure out a number. So I have two numbers here, y0 for both the first and second, for the original equation and the first derivative. So let me write down those rules here. So y of 0 and y first derivative of 0. Okay. So now that I have this available here, what I would do is y0 equal to -1, and then y of 0, y derivative of 0 is equal to 1 here. So let me write those. -1 equal to 1. Now this is equal to y. I need to get y prime. In this case, judging by what I have here, this function here, the C1 and C2 I can ignore, but I cannot ignore what's in the trigonometric identities, their parentheses. Cannot ignore that. So this, bring this up, the derivative cosine here is negative sine, and then I bring this 3 to the front. So -3 sine, actually no, that's correct, but I'm missing the C1. -3 C1 sine 3t. And then this one is also the same thing, but it's for cosine. And then this is cosine, if it allows me to write it, 3t. Okay, so those are the derivatives. Now the secondary goal will be, okay, how do you actually decompose this? How do you break this down into something useful for the average person? So what I would do from breaking this down here would be, okay, we have this. Now we need to set it equal to the corresponding numbers. So when y is equal to 0, equal to -1, this sine function goes away. So I just have C1 here. So -1 is equal to C1. And that's from this first equation. Now for the second equation, y prime is equal to 1. Now in this case, C1 goes away because sine in this function will be 0, and sine of 0 is 0. In this case, though, when I have 3ct, c2, and I have a 0 for the cosine, that's 1. So I have 3c2 equal to 3c2. It's pretty easy generally. So far, anyway. It will get harder as time goes on. So what I can do is this becomes, just divide 1/3 is equal to c2. Right? And I think I can What can I do? I think I could select things. I can. Yes, I can select things and just start moving them. That's actually very useful. So in this case, using this information, I could just now plug it back into this original equation. So y is equal to -1, remove the c1, cosine. Actually, I don't even need that. I just need to put negative cosine here. The 1 is assumed. And then it would be 3t. And then 1/3 plus 1/3 sine 3t. And this would be the general solution. And then past this point, just looking at it generally, anything I want to plug in would work. Okay, so looking at 4 now, this is where it should get a little bit more difficult. I have to start thinking a bit more about the choices that I am about to make. It is actually not that easy to do this. Okay, so an accident at a nuclear power plant has left the surrounding area polluted with radioactive material that decays naturally. The AFC denote the amount of radioactive substance time t in months. Okay, so what I'll do, I'll take a picture of this function right here. Take a picture of it. And then I believe I can just put an image in there. No, I'm not trying to do that. You can't just put images in. Should remove background. Okay, can you not like put images in here? Or can you? Okay, there we go. So this is what 4 is. It's very easy to tell. Alright, so this is 4. And this is what I'm trying to do. So just looking at it, this is our base function. This is the change. The thing I'm trying to figure out though is I have an initial amount of 20 SU safe units. So I believe A in this case is safe units. So A of 0. A of 0 is 20 SU. So that will be at the end. And find after t months. So then that will be the function that I'd be looking for. So I have to calculate this function. So in this case, this is generally pretty easy and not too difficult to deal with, I would say. So key things to note, and I'll highlight them in this function. I can separate, that's not correct. I can separate this equation right here. So I can separate this, move this over, and then move time over here, integrate for time, and then get a time function. Other thing I can do is, because I know what the initial safe units are, once I get to a point where I have a function that has a, which this function will simplify to just a. At the end, I just plug that number in, and then what I do is just basically find the function for t, and then if I know what t is now, like 20 safe units initial, find r if 10 months later the amount of radioactivity is 5 SU. If I put 5 in here and it drops by 15, I think I can pretty much estimate a lot. But let me try to actually figure out how I would do this. So in this case, I have dA dt, dt, and then using this function here, -3a, -ra. What I ideally want to do is to move this dt here and to move my a into this denominator. So that's exactly what I'm going to do. So I'm going to rewrite the function this way over a. I'm going to keep the negative on this end. And then I will have this equal to -r dt. Now just from an integration perspective, I have ln a on one end, and I have -RT on the other end. this is what I will get. Now I have to do E on both sides. So I get I would get A here. Yeah, A here is equal to E to the negative RT. So that's what I have. So what this would be is, okay, find the amount of AT of radioactive material remaining after T months. Right? So this is my base function here. Another thing I could do, because I know this is 20, I want to figure out what my R is. So at the very initial is when T is equal to 0. So at A of 0 is equal to 20. So in my case, I would have 20. In my case, I would have 20 here is equal to, in this case, this would be 0. Actually, now I'm thinking about it, this would be plus C. You have a plus C here. I just thought about that. I kind of just thought about that, actually. That, wait, you'd get a plus C here. You'd also get a constant here, but it will move over here anyway. And then, if you're going to have E to the C, you might as well have that be, I don't know, actually. That is a good question. Because now I'm thinking that, okay, to the C, this would still be a constant number. It's not going to be a variable. That's actually a good way to put it. This wouldn't be a variable. So I could think of what the C multiplied here would be. Should be adding two E's together. I believe that's something that you can do. So I'll have this here. If I put this above E, then I have E to the C, then I have a C and like prime here. So whatever this constant function is, we're going to still put it as a C because it'll still be a constant. Whatever this is will have to equal some form of 20, I believe. But I think this may be incorrect. Because if I were to do this way, then this would become a larger C. And because these have the same bases, and you'd be adding their exponents, from what I remember, I'm trying to remember my exponent rules. Remembering exponent rules is a little bit difficult now. What would I do here? Now I'm actually getting stuck because I have C here, and I know it's a constant. So even if I have it here, this will still be a constant as well. I'm trying to remember, was this factored onto the C? Because that would make sense. Because if this is 0, then this is 1. So I would imagine that my C, my constant C here, would not be 19. I'd imagine that this C, e to the C here, from my experience, I imagine this will come down and be a multiplied greater C in front of here. So I'll take it as that. I could have a larger C, e to the negative 3t. And I'll assume EC here would be 20 to make this work, because this being 19 wouldn't make sense. It just doesn't make sense in most circumstances. Okay, so this would become 0, so it's time to turn this to 1. So this C is equal to 20. But now that I know that, in this case, now that I know that, the real question now is, okay, what does R have to be? Hey Chase, what's going on? Welcome to stream. Yeah, so what does R have to be if T is 10 and A is 5? So put 5 here. This has to be part B of the equation. So this would be part A. So 20 is equal to 20 E negative RT. Something like this. This part is the only part I'm not super confident about, but this portion here I know is correct. So just do part B here. Just bring this over. If but 5 is equal to this function here, and it's after 10 months. You can't really use a calculator here. You're not allowed to do that. Okay, so negative r times 10. All right, so to make this work, I'm going to have to drop the 20. So I get 1/4 is equal to this, or e to the e to the 10 negative 10r. Now, if I take a natural log of both sides, this function here would just come down. So this function here up top just comes down. These cancel. So I'd imagine this turns into directly, you have ln 4. You have ln 1/4, but that would just simplify into negative ln 4. Reason being, ln 1 turns to 0, and natural log, this function, when it's in this feature here, is just ln your first number minus your second number. Why math? The reason I'm doing math is both because people kind of talked about a homework stream earlier, but also the fact that I have like a test in like a day or so. So this is good practice. Both good practice and good content. So I might as well do it. But someone can always look back at this as well. But the main reason is I have a test. So I have to just know how to do this. Okay, so this is negative ln 4. I remember what this is. This is negative 10r. So then I could just divide this over. So the ln 4 over 10 is equal to what my r would be. That's what my r would be in this case. So that could work. That should work. So I have part A, which I'll highlight with this. I'll highlight it with its pink color. That's my answer for part A. And then for part B, this is my answer. All right, on to the next one. I think I have question 5. Yes, and this one has 3 parts to it. And I just have one more question after this. Oh my goodness. Okay, so question 5. This is a pretty long one. Okay, so define a general solution. Determine the values of A, if any, for which solution send to 0. Okay, so now I'm trying to think if this is like a repeated root problem, but I gotta see. I'm apparently not subscribed on here. Oh, really? I mean, YouTube might like randomly unsubscribe people, but I don't think that happens too often. They usually do that when they suspect people are bots. That's usually what they do. And by they, I mean their algorithm, not the people who work there. Okay. This is my function. I think my teacher did this. Yes, my teacher did do this. Minus 4. But this right, hold on. The function that I'm thinking of, this is not, whatchamacallit, this is not a binomial expression by any means. It does not qualify as a binomial expression. If anything, it's quite distant from a binomial expression. And should not really be treated as such. From at least how I'm seeing it. Also because I don't normally watch YT on here. Yeah, that's another thing, yeah. That could be. If you don't watch YouTube on that account, you probably aren't subscribed to too many channels on that account. Alright. Let me get back to this. Okay, if this was the actual exam, I have about 30 more minutes, so I'd actually be in good shape if this was the exam. Thing is though, there's a reduction problem after this, and that's going to take an extremely long amount of time. But I'm also distracted, so the fact that I'm actually able to get this done in a reasonable amount of time is actually quite good for myself. So I have to give myself credit where credit is due. Okay, this is 2a minus 1, and this is in front of y. This is all equal to 0. Now I have to find a general solution. Determine the values of a, if any, for which the solutions tend to 0. Determine, if any, which all non-zero solutions become unbounded. Okay, so I think the last two are pretty easy to answer. The harder part is going to be more so this middle section. Hey Nacho, welcome to the stream. I'm doing math problems. How are you doing? Alright, so finding a general solution, at least from this function, just giving it a general look, it's kind of like finding... I mean, it is like finding a root, though. I am being honest. Like, that's what it is. But from this perspective, what type of function is this? I'm trying to think if this is either the... I don't believe it's 3.5 with a polynomial method. I don't believe that's the case here. Because I don't have a function. There's no function here. Because there's no function here, it can't be the material from 3.5. There's no function there. So I think I have to just simplify these. 2a. Okay, 2a, 2a. That's 4a squared. Let's just get this binomial factored. This is just 4a squared. And then these cancel. 2a minus 1. That cancels. And then this is just -1 here. Okay. So that's easier. Should make it easier. Generally. In my case, I'm more so trying to find roots. So if I were to convert it this way, for a r, I think I'm doing this wrong. Like I definitely know that I'm doing this incorrectly. It's a good r. I know that for sure. And then this is just a function. But this is plus. Now, from this perspective, I don't know any factors that multiply into make this. But I think there could be another method for this besides factoring. Just giving it a decent look, or looking back at what has already been done. I think most likely it might be most similar to this problem. That's what I'm thinking it is. I think this isn't reduction. This is actually exponents. But I think in that case, integration factor wouldn't really work here. Because we don't have... Yeah, that's another good one. That's actually really good. I don't have a thing to do integration factor. Well, I gotta go. I might be back later. Alright, Chase. Thank you for being here. Yeah, for this, I don't have an integration factor. I can't do integration factor. I can't do separable equations. Because I do not have a d alpha dt. And I cannot do the method from 3.5. All of those are off the table. But maybe there is a way. Maybe there is a way. Because the general solution here is more I have to find roots. If I could find the roots, this would be way easier to get done. A general solution here, though, what would that actually entail and what would that look like? Is it actual? Good question. But I actually don't really have the answers to at the moment. Because this is it's the way I'm thinking about it. This is actually a decent amount of thinking that has to go on here. Because I have the fully factored form. And I would have the R. The thing is, in this case, because I would have a negative R here. There's no real circumstance. Actually, no. I believe there would be, actually. Or maybe not. Now this is the type of problem that can get me confused. But I'd imagine it's already been done. So what I'll briefly do is I'll look for a problem similar to this. And if I can't figure it out, I'll skip to the next one and move on. Just so I don't get permanently stuck, because that would not be ideal. But just giving it a look, generally, it's quite complex. Because that would be constant coefficients. But maybe I can, because I think it is a constant coefficients problem. Maybe, just looking at it, because I'm not going to be able to factor this on my own, do my head. What I could do is I can use a quadratic formula for this. I just realized that. I can use a quadratic formula for this, and I can get something to work here. Because in this case, if you don't know, the quadratic formula basically would be a squared. The coefficients, not the actual numbers. A squared plus b, the variable, plus c. Ax, bx, let's see. In my case, I have my variables, and I know what all of them are. So the only thing I really need to do is get this coefficient. So this is -4. This becomes 4. And then I have plus or minus this square root. And then -4 squared is 16. Minus 4ac. I have a 1 here. So that's not what I'm looking for. Minus 4a squared. Minus 1. And in this case, from what I would get, most likely, as I move this over, I would get -16a squared minus, plus 4. Not minus 4, plus 4. So I would most likely get, in this case, -4 times -1. So I would get 20. Plus, minus 16 squared. 16a alpha squared. And actually, now I'm thinking about it, Now that I am thinking about it in a more complex way, maybe actually putting the coefficients in here would be good because the coefficients here include a. So I think I actually made a mistake here. I need to include a squared here, and then these cancel. So 16a squared from this minus. Actually, whip out the eraser here. 16a squared minus 16a squared plus, in this case, -4 times -1, that's 4, which would just be 4 square root 2. Square root of 4 is just 2. So I have 4a in this case, square root plus or minus this function, which simply just turns into square root 4, which is just 2. So I simplify all of this down here, and I'll make it easy for everyone to see it. It will be square root 4 as a simplification, and then I would just get 2 from this. So now I will get 4a plus or minus 2 over 2, which can be simplified further into 2a plus 1. Well, plus or minus 1. So those could be my roots. And in these cases, these are not repeated roots. These are different roots. So the general solution here would actually be pretty easy to figure out. And now the easy part is everything that I just got. So it would be C1 e to 2a plus, well, no, plus or minus 1 here. And then it would be to the t power. And then it would be not plus or minus 1, but it would be plus 1 for t, and then plus c2 e to a minus 1. Now, parts B, this is my general solution. This is equal to y. Let's add a t here. My handwriting is not the best, but this is what the general solution would be. So, general solution. And my handwriting, even though it's bad, I can speak well enough to convey information. Okay, so now looking from this perspective at the problem, what would be next in this case, from my perspective, would be, okay, if question B, part B of this problem is asking, determine the values of alpha for, if any, for which all solutions tend to 0 as t goes to infinity. So let's get this here. T goes to infinity. We have alpha. The real question here is going to be, okay, what values can I plug into here, even though it's hard to see, for t? Well, t goes to infinity. What values can I plug in for alpha that are going to make this entire function, at least in this case, go to 0 over time? So I want all features to go to 0. All functions to 0. To get this, what I want here, specifically, is that I want an alpha that works for both this function and this function. So I'd want a 2a in this case plus 1 is equal to 0, and then 2a minus 1. Now, for this case, the only thing I'd really want for the one on the right is I'd want the number to be high, to be low enough for this to not matter, for this to always be negative, which is pretty easy to do. But for this left one, this is the one I actually need to balance out. So I'd want to subtract 1, and then I have 2a is equal to -1. And this would be roughly the dividing line here, where this function goes to 0, and then this function doesn't exist, and then this function just always goes to 0 here. But it would be anything lower than this specific number. So let's get this. A would be equal to, in this case, 1/2 negative. Now, -1/2 here, you get -1 plus 1. This t goes away, 0t, so you just get c1. Anything below this value will give us 0 for all solutions. So when alpha is less than this function, less than -1/2, all solutions go to 0. All functions go to 0. Whereas part C is very easy to answer because it's a continuation of this problem. For part C, the question was, for that, it would have been, okay, determine the value of A, if any, for which all non-zero solutions become unbounded. So basically, what that's saying to me is, when does alpha appear? At what value past that point or greater do all values go to infinity? That's what it's asking. So in this case, for C, it's just this question, but anything that is less than this case, in this case, is greater than -1/2, all go to infinity. It is only at -1/2 for alpha where you get one defined value. But if you're less than -1/2 for this particular equation here, then this function will go to 0. Whereas if it's greater than -1/2 as for alpha, this function, especially C1, will go to infinity over time. That was question 5. And on to the last question now. This is reduction. This will take a while. I will highlight this answer. Highlight both of these. So I'll highlight my explanations for both of them. So I'll just highlight this. This was the general solution. So let's get to number 6, and I'll just copy paste the question itself. So I'm not going to write it because people are not going to be able to understand what it is, because my handwriting's not decent enough right now. There we go. So just looking at this generally, considering the following differential equation, we have this, and we are given a solution. So for example, we are given y1. We know what y1 is, but now we have to find what y2 is. And then we have to show that this is a fundamental set of solutions, which is pretty easy. That's just doing a Ronskin. So I'll show you how to do. Okay, so from this perspective, the first thing that needs to happen is that this function needs to get reduced. Yeah, so the first thing that needs to happen is this function needs to be physically reduced. So I will show all the steps on how you'd reduce this function. So I'm going to be using the Ronskin method because that's the one that it's easier, at least for me, to remember. There is another one where you plug in what y2 would be using the v method and then integrating that, but that may not always work. Okay, so And this is a condition. I don't want this to be here. So t like that. So this is our condition, but we can pretty much ignore this. And y1 t is equal to t. Now we're going to divide this by t squared. So divide t squared here from all the terms, because we want this front term to be isolated. So this grants us the following equation. Now for this, it looks similar to the integration factor problem. It is, but it's not a direct one-to-one comparison. So why don't you just put y over here? Not a direct one-to-one comparison. And then this here, 0. Now, we know what y1 is. Y1 is an important function. But we will get to this part later. So for the purposes, what we're doing right now, we're still going to identify where our PT is. However, this will be different than what we did originally, because the function for this is going to be a negative. It's going to be, I'll actually make this the formula in red, just to make it easy. Orange to make it easier to understand. The formula for this is slightly different than for the integration factor, because our PT is going to be integrated in a negative fashion. And then this will be what we use after we do a RON scan to integrate and then continue the rest of the lineage after that point for the math. So we're going to be using this formula to really understand what's going on here. In this case, ignore the y. Our PT is negative 1t. So in our case, of a negative integral of negative 1t, what happens here, these two negatives will cancel out. So what will happen is I would just get 1 over t, the integral of that, and I'll just get ln t over e, which just becomes t. We're going to save this for later, and I'll be bringing this down as time goes on. That will be brought down. Okay. What else are we looking for? Okay, so now that this has been brought down, we're doing a RON scan. So y2 is supposedly going to be v times y1. And y1 in our case is actually t. So we'll run with it. But we're going to use our RON scan here. And we'll have t here, 1, and then v times t. Well, v multiplied by t. And then in this case, we have two different derivatives, v prime times t, which will still be a thing, and then plus v. Okay, so we have this. Now we cross multiply. So if you don't know the form for this, it's AB, well, AD. So this is A, this is B, this is D, and then this is D, and this is C. And then what we would do here is that you factor this over, and we can work around this. So what we do is t into here. So we'd have v t squared here, and then that would be plus vt. And then 1 would be minusing this factor here, this bc factor, which would be minus vt. So in the end, we would just get this here into our RON scan, and then we're going to be bringing this little thing down here, and this is where the rest of the problem will continue. The final proportion of the problem will continue from this point onward. Okay. Oh my goodness. Oof. Trying your best around here is a bit difficult, I will admit, but you know, always try your best. Okay, so from this, just something to note. We want this V to be by itself, so I'm going to do is we're gonna highlight this box in red. I'm gonna highlight it. And what we're gonna do is we're going to transfer this t squared and we're going to put it underneath here. All right, that's what we're going to do. Okay, and then this would simply simplify to 1 over t is equal to v prime. Integrate both sides. V is equal to, in our case, ln t is equal to v. Well, ln t plus c. But if this is our v, then we have to multiply it again. So ln t plus c, due to the formula being this, our y1 in our case is t, so we factor this in, and then we would get ln t times t, or the better way to write it out, you could simplify this to t ln t. I know it can get quite confusing, but it can look, that's how it would look. And then you get plus ct. Plus ct. Okay? Now with that plus ct, you're in a generally good position. Okay, so this can be considered just like the normal constant. And if we were trying to find a general solution, we have this. So we found the second solution, which in our case would just be y2 is equal to, y2 is equal to t ln t, and that is our solution here. And then to prove that these are a fundamental set of solutions, we have t here, and then we have 1 t ln t here, and then we take a derivative of this, so you get ln t in one case, and then you'd have t times 1 over t, which would give us 1, so b plus 1. So now when we do the math here, another cross product rule, get t ln t plus t, plus t here, minus t ln t, and these factors cancel, so cancel those factors. Cancel common factors. And then from this point onward, you would just have t, which is not, well, you would just have t, which is not equal to 0. So we do have a fundamental set. Fundamental set of solutions. And if this was real life, most likely I would have got it. Well, I would have finished everything, but would I have gotten everything right? I don't believe so. But things do happen. But I mean, I had fun doing this. So yeah, that was all the math I have. So this is a review. This is where we started up here with all of the different variables. So identifying whether this was linear, we said that this was not due to the presence of this outside factor. Now, I do believe that this could also sometimes be interpreted as an exponent, which just could be considered d to the 7. I have to look at this more. This is a potential mistake. But if this is correct, this would be nonlinear. This is my direction field. And then we have a bunch of other different formulas here. This is separation of equations, separable equations, and then this was the final equation, the general solution I got here. And then we worked through integration factor, which gave us this problem here. I'll actually need to highlight this because I didn't highlight it already. But this is the answer that I did. And then complex fruit, I divided this, got the complex root, got this plus minus 3i, and was able to create this constant form. Found the two constants, and then this was my final form for this question here. This was a regular activity question, so I just labeled everything here as is. Clearly, so everything's clearly understandable. dA dt, negative RA, had to find a formula for A. I decided to put the C here because it wouldn't make sense to have a constant sitting here. It would be part of E, be multiplied by it, because it's also to the E power. So it would be in front. And then this is what I achieved here. And then this is my second answer. All right. So that looks pretty good. So I probably can't wait. I'll probably post this now, but yeah, I did well. Yeah. So thank you guys for watching. A few of you who did watch. I wouldn't expect too many people to really watch this stream, but to be fair, the information I did provide was pretty good, decent. So I think this will help people that it was necessary for. All right. Goodbye. I will probably be doing another stream. Maybe tonight. I might just start work on my research proposal instead. That will be a wiser idea instead of streaming, but we'll see what happens.